So this one, I think I curved out of the test, but let's go ahead and talk about it anyway. The idea for solving for a variable is to, well, get the variable by itself. Now what I like to do when I do any solving problem is visually or mentally, I sort of highlight the variable they're asking me to solve. So since the problem says solve for h, it's as if I highlight all the h's. So your goal is to get rid of everything that's not highlighted. Now notice the 2L and 2W are attached to the h's, so I can't deal with them just yet. This term is completely without h's, so we can go ahead and get rid of him by subtracting him to the other side. This gives us s minus 2LW. Remember, if they're not like terms, just leave it separate. Equals 2LH plus 2WH. Now notice the variable that I'm trying to solve for, h, is in two separate terms I can't combine. So the idea is, if you have multiple terms that contain the same variable that you want to solve for, you factor him out. It's just the same thing as like factoring a GCF, the greatest common factor. And now when you factor him out, we only have one term with the h that I want. So all I have to do is get rid of the thing that's not h. So I get rid of the 2L plus 2W, and I get rid of him by dividing. And then our result is as follows. H is by itself, so there's our answer. Number 2 is just a simple, solving for this. It's the same concept, solving for a letter. Again, when I ask you to solve for a particular letter, it's as if that letter is highlighted. And your job is to bring all the highlights together and move all the non-highlights to the other side. So I like to keep the thing I'm solving for positive. So let's go ahead and add this k over. That's 7j. These guys are gone. I didn't do anything with this j, so I'll just bring him down. And 6k plus 1k is 7k. Let's go ahead and get rid of this j here. That's 6j equals 7k. And then the last step is to get rid of that 7. 6j over 7 equals k. The variable that I'm asking you to solve for is by itself. So that's the answer. Number 3 was just a simple solving for a variable. So the idea to solve an equation is to get rid of the thing that's farthest away first. So if this is the variable that we're asked to solve for, notice that the plus 7 is sort of like farther away. It's not attached to the variable p like the 18 is. So I'm going to get rid of the plus 7 first by minusing the 7. And then to get rid of a fraction is the same thing as division. So to get rid of this divided by 18, you go ahead and multiply by 18. So p equals 36. Number 4, more solving equations. Just most of the tests was solving equations. That's what Unit 1 was all about. So I get rid of the thing that's farthest away first. I'll go ahead and minus 3 on both sides because I want to get the 3n, or namely the n by itself. And then to get rid of that 3, we divide. That's negative 29. No, I can't divide. That's 19. That is 19. Absolute value inequalities. So this is sort of the idea. Notice that we are dealing with a less than symbol. So the setup is, anytime you have an absolute value with an inequality, specifically a less than symbol, you set it. All you do is you surround the stuff inside the absolute value between the positive and the negative of that number using less than symbols. So that's the setup. If you have this, you're going to transform it into that. So in our example, absolute value x plus 7 less than or equal to 8, I'm going to trap what's inside the absolute value, the x plus 7, between less than symbols, and between the positive and the negative. And then all I got to do is just get the x by itself. In this case, it was just one single step. I'm going to minus the 7, but since it's a compound inequality, you have to do it to all three sides. So that gives you negative 15 less than or equal to x less than or equal to 1. Number 6 was an absolute value greater than problem. So again, the idea was, or the setup was, if you have absolute value stuff which is greater than a number, it's going to be a compound OR problem. So you write down the problem as is without the bars, or the stuff inside the absolute value, you flip the inequality, you flip the sign on the number. So in this particular instance, if we have absolute value of d plus 2 is greater than 2, my two setups would be the normal problem as is, d plus 2 is greater than 2, put the OR there, and then the stuff inside the absolute value, d plus 2, flip the symbol, and then you just go ahead and solve these two equations, or excuse me, two inequalities, using the same steps. You're going to have the minus 2, giving you a d is greater than 0, or minus 2, d is less than negative 4. Now technically, since this is a compound inequality, both of these guys together, joined together with OR, is the solution. I had a lot of people not use the word OR. It is a compound inequality, so we do have to join these guys together. That is the full answer. Number 7, evaluation. If I give you an expression with a whole bunch of numbers, but I do, or excuse me, it's a whole bunch of letters, but I do tell you what those letters mean, all you have to do is just change those letters into what the numbers I tell you. So for in this instance, it says every single time you see an M, it's going to be a 3. Every single time you see an N, it's going to be a negative 1. And I always use parentheses when I substitute. So this guy here becomes 2, instead of writing an M, I'm write parentheses 3, plus 2, instead of writing an N, I'll write parentheses negative 1. And then all you got to do is do the arithmetic. That's 6 minus 2, which is 4. Same concept here. This is an evaluation problem. According to the problem, every time I see an E, change it to a negative 1. Every single time I see an F, change it to a 5. So this is 4, negative 1, plus 3, 5. And then you just go ahead and do the arithmetic. Negative 4 plus 15 is 11. So word problems, I always just like to see the information they give us. So you're saving money to buy a new basketball that costs $58. You have $36 saved. How much more money do you need to save? I always like to highlight the question as well, because that's usually going to be the variable. So how much more, this is the actual question, how much more money do you need to save? So that's the variable. And then, since this is a multiple choice question, all you have to do is, find the pieces. It says the new basketball costs $58. So the cost is $58. If you skim your choices, here's the two choices that say cost is $58. It says you served $36. So which one says you saved $36? This one here is the one that says you saved $36. Which one here asks you to find how much more money you need to save? That's a variable. This one here. So before even solving, before setting the equation, just by process of elimination, I'm going to let the answers be. more solving for a particular variable. This one might have been, quote, hard because of the fraction, but you should not have let fractions scare you. If you're solving for a particular variable, I imagine if it's highlighted and I get rid of the things that are not highlighted, hopefully everyone can see that this x is farthest away. It's not attached to my highlighted y. So let's get rid of it by minusing the x. This gives you 1/2 y equals negative x minus 1/3. I just like to write the x first, that's why. If you wrote negative 1/3 minus x, that would have been fine as well. And then to get rid of this 1/2, hopefully you remember from Algebra 1 that to get rid of a fractional coefficient, you multiply by the reciprocal, which in this case is just 2/1, or simply the number 2. So these guys cancel, that gives you y equals, and then if you just distribute the 2 in, that gives you negative 2x minus 2/3. More word problems, so let's just highlight the information that they give us. So you're printing, you need to raise money. The print shop charges $3 for each book. Now, in word problems or conceptually, if you have an expense, or if you have something that adds for every something, you get charged this for each book, you make $10 per hour. Any type of number or quantity that is constantly changing, that's usually going to be the one that's attached to the variable. We have a one-time fee of $45. Anything that happens just one time will not be attached to the variable, and the variable will always be whatever it is that you're asking. So it's asking for how many books. So I'm going to let that be my variable. X equals the number of books. And then they give us this information. The budget is $525. Budget is like the total amount of money you spend. So when setting up an equation, you usually put totals on one side of the equal sign. So I'm going to talk about 525 equals. I started with 525 because you usually start with the totals. So this 525 is talking about money. So everything I put on this side of the equation should be about money. Well, what information do I have that relates to money? Well, I know it's $3 per book. And again, anything that happens repeatedly will be usually the thing that's multiplying the variable. We have a one-time fee of $45, and that is usually something that's not attached to the variable. Here's our equation. All we have to do is solve for x. Minus the 45, minus the 45. That's 480. And then divide up to 3. So you get x equals 160, which is, since it's multiple choice, is choice A. Number 12, just more solving equations. The majority of this test was just solving equations. This is an example of an equation with variables on both sides. So the idea is to move all the variables onto one side, move all the non-variables to the other. Hopefully by problem number 12, we're a little bit better at this. So I'm going to try to do the 2 steps at once. I like to keep my variables positive, so I'm going to move all the variables to the right. So let's subtract the 6z, which means I'm going to move all the regular numbers to the left. Let's see if at the same time we cannot add 5 on both sides. What would that give us? These guys are gone. That's 8. This is 2z. These guys are gone. And then one more step, get rid of the 2 via division. Z is 4. More solving equations. One of my hints was before you do any actual solving, simplify the problems. And we all should know that if you have a number in front of parentheses, that usually tells you distribute. So before I even try to solve, I'm going to clean this up a bit. That's 5n. Remember, when you distribute, you always distribute the sign as well. So distribute a -2, please. So distributing a -2 gives us a -4 plus 2n. We'll go ahead and combine like terms here. So that gives us a 7n. Now that things are cleaned up, we can go ahead and solve for the variable. Let's add 4 to both sides, and then divide up the 7. N equals -3/7. Number 14 is another solving equations, almost an identical question. Did I put two of the same? No, guess it's just the same concept. 5n minus 2, n minus 2 equals -11. So if you got 13, you should have gotten 14 as well. Clean him up by distributing a -2. 5n minus 2n plus 4 equals -11. Combine like terms here. So that's 3n plus 4 equals -11. Subtract the 4. 3n equals -15. Divide up the 5, n equals, or excuse me, divide up the 3, and you get n equals -5. Number 15 was more solving, but it just looks harder, but it's the same concept. If you have an equation that looks really ugly, looks really long and messy, the idea is to not dive into it with solving, but instead clean them up a bit, simplify him. So on the left-hand side, we can go ahead and combine like terms. On the right-hand side, we can go ahead and distribute the negative. So that gives us 3x plus 14. On the right-hand side, distributing the negative makes it a minus 4x minus 2. I can go ahead and combine like terms on the right. There's really nothing left for me to do on the left, so just copy them down. When you're solving an equation, any part of the problem you don't touch or don't work on, just copy them down. So combining 9 with the -2 gives me a 7. And then this is a variables on both sides situation. Move all the variables on one side, move all the non-variables to the other. Hopefully we can do this in 2 steps in one. I'm going to go ahead and add 4x to both sides, but at the same time, let's subtract the 14. This gives us a 7x. These guys are gone. Equals -7. These guys are gone. And then to solve for x, you divide out a 7. Gives us a -1. Number 16 is just more solving. Hopefully we can be a little bit more automatic with these types of problems now. Plus 6t, plus 6t, plus 9, plus 9. That's 7t. These guys are gone. Equals, these guys are gone. 7. Divide out a 7, you get t equals a +1. Now, simplifying an expression, it uses the same combining like terms, distributive property techniques as with solving. The only difference is, since it is not an equation, there's no equal sign, you should not get a numerical answer. Your answer should contain variables in it. But the idea is the same. When I see stuff in front of parentheses that tells me to distribute, be mindful that you're distributing a -2 for the second parentheses. So that gives us 5a minus 5 minus 2a plus 2, and then you just go ahead and combine like terms. So when you combine like terms, the blue, 5a with -2a gives me 3a, and whatever the other color is, green, orange, I don't know, the -5 plus 2 is a -3. So that should have been number 17. Number 18, more of the same thing. You're just combining like terms. So we have -4f minus 8 minus 8f plus 7. So your like terms are your f terms and your constant terms. So put them together. Let's start with the blue. -4f with -8f is -12f. And then the other color, -8 with the +7 gives you a -1. This one here you have to read carefully. You and 4 friends, which means 5 people in total. I think if you made a mistake, that's probably where you made a mistake there. Each ticket costs $4.25 each. You each buy a drink for $2.75, and you each buy a box of popcorn for $3.75, how much money did you spend in total? So every single person is going to spend $4.25 for a ticket, plus $2.75 for a drink, plus $3.75 for a box of popcorn. So this is the amount of money every single person spends. So we have more than one people. We have 5 people in total, so you have to multiply everything by 5. So what is that? So $4.25 plus $2.75 is $7, plus $3.75 is $10.75. So you go ahead and multiply out $10.75 by 5 people, and you get $53.75. So every single person, or rather, you all total spent $53.75. So I think this one I took straight from the homework, but let's go ahead and talk about it. So again, word problems, I just focus on the information they give me. A person is able to burn 7 calories per minute on an exercise bike. So 7 calories per minute relates to exercise bike, 10 calories per minute rowing. So we have 7 cal per minute for the bike, 10 calories per minute rowing. You spend a total of 1 hour exercising. So again, typically when you build an equation, if they give you totals, that's usually going to be on its own on one side of an equation. Now notice it gave us 1 hour, but the other information is per minute. So I'm going to convert that hour into minutes. So that's 60 minutes total. And it asks, and it tells you, let me highlight here, you burn a total of 525 calories. So 525 calories total. How long did the person spend riding their exercise bike? So we're looking for, so that's the question. How long did the person spend riding on the exercise bike? So usually whatever the question asks, that's your variable. X equals the number of minutes on your bike. So let's set up the equation. We got 2 totals here, minutes and calories. If you read the whole story, I hope everyone can see that the main story, the main topic of the word problem is burning calories. So I'm going to start off with talking about calories. Calories equals, well, we only did 2 things, riding a bike and rowing. According to the problem, we burn 7 calories per minute for every minute on the bike. And the number of minutes on the bike is our variable, so we're going to attach these x to the 7. But we also lose calories rowing. We lose 10 calories for every minute we row. How long do we row, though? Well, it tells us that we exercise for 60 minutes total, and x of those minutes are on the bike. So the leftover minutes, 60 minus x, must be the minutes we spent rowing. There's our equation to solve. Go ahead and distribute the 10. 525 equals 7x plus 600 minus 10x. You can combine like terms if you want. Here's the like terms. 525 equals 600 minus 3x. Subtract the 600. Negative 1, what's that? Oh, negative 75 equals negative 3x. And then divide out the negative 3. You get 25. So, and x was the number of minutes on the bike, which is what they asked us to solve for. So the answer is 25 minutes. How long does it take to travel 150 miles at an average speed of 6 miles per hour? This should have been like common sense if you know how speed works. But one of the techniques or ideas was if you have no idea what to do, you can sort of look at the units. So the information they gave us was 150 miles, average speed of 60 miles per hour, and the question is how long, which is time. And if you read the problem, time is in hours. So they want to find hours. What is the hours if I give you miles and miles per hour? So this is what it's asking us, and this is the information that they gave us. Now I hope it's sort of a very obvious, straightforward sentence, but I hope everyone agrees that to get miles per hour, you take miles and you divide it by hours. I mean, you just set up the units as is. So I hope everyone can see that blue, miles per hour, blue is just yellow divided by orange, whatever this color is, hours. And then all you got to do is fill in the information they gave us. Well, they gave us the blue, which was 60 miles per hour. They gave us the yellow, which was 150 miles. They did not give us the orange. That's actually the actual question, so we'll call that X. So all you got to do is solve for X. Let's move this guy over here. I'm just going to rewrite it without the units. So to solve for X, I need to get X off of the denominator. So opposite of dividing is multiplication. Multiply both sides by X, and then divide out the 60. And then all you have to do is reduce your fractions. You can slice out a 0, and then you can divide out a 3. So that's 5 halves, and the units were hours. Solving number 22 is all about solving an inequality. Solving inequality should be like 99% the same as solving an equation. There's just only one rule. If you multiply or divide by negative, you reverse your inequality. That's why I try to keep the variables positive as much as possible, so I can bypass or skip this rule. But other than that, inverse operations, get the variables on one side, get the regular numbers on the other side, all of those ideas and logic should be 100% the same. So hopefully we can do this 2 steps at once. To keep the variables positive, I'll go ahead and add 7v to both sides while simultaneously subtracting 14. Negative 6v with 7v is one single v. These guys are gone. Symbol. These guys are gone. And 9 minus 14 is a negative 5. What do you know? The variable's by itself? That's my answer. Solving for a letter in a multivariable equation. Again, I like to imagine as if the thing that I'm solving for is highlighted. So I get rid of the thing that's, not highlighted. Normally, people would say, oh yeah, this negative 11 is farthest away first, so we'll get rid of it. But notice it's trapped inside the parentheses, so we have to get rid of that parentheses first. Hopefully you guys remember from Algebra 1, to get rid of a fractional coefficient, you multiply by the reciprocal. So I'm going to multiply both sides by 5/3. Because when you do that, the 5 cancels out, the 3 cancels out. So you're left with 5/3 b equals a minus 11. That a is highlighted. And then to get rid of the minus 11, you go ahead and add 11 to both sides. A is by itself, so that's our answer. Now, when it comes to these like rewriting formulas or solving for a variable in a multivariable equation, there are a lot of different ways that these problems can look. So this isn't the only structure you could have had. Let's say, for instance, you took this route. Right. Say you didn't want to multiply by the reciprocal, but you did want to get rid of the fraction, the divide by 5. So I could have multiplied both sides by 5, got rid of the denominator, and let's say for whatever reason you felt like distributing the 3. So that's 5b equals 3a minus 33. Then you added the 33, and then you divided by 3. You would have gotten 5b plus 33 over 3 equals a. The variable a is by itself, so that is also a possible answer. So these guys can look many different ways because you don't have like terms, but they're both perfectly valid. Number 24, which is a simple solving equations. I hope that I don't have to go through the full bore explanations. We've already did it with the problems earlier. So, subtract the 12, divide out the 4. Easy peasy. Absolute value equations. The setup is as follows. If you have absolute value stuff and it equals anything, variables, letters, what have you, I'll use the letter C again. The setup is this. You're going to always write two equations. That stuff inside the absolute value equaling the normal. So write the problem as is normally. But for your second equation, you're going to take the opposite of that stuff and setting it equal to whatever's on the other side. So in this particular instance, we have absolute value of x plus 1 equaling 4x. That means one equation will just be the normal equation. But the other equation, the other possibility, is it could be the opposite of x plus 1 equals 4x. And then all you have to do is solve these two equations separately. On the left here, let's go ahead and subtract the x over, giving us 1 equals 3x, and then divide out the 3, you get a third. Over here, some students like to distribute the negative. I like to divide up the negative. Either way is perfectly fine. You get x plus 1 equals negative 4x, and then you subtract the same step, subtract the x, and then divide out the 5. Now, the instruction did say check for extruding solutions, so I was trying to give you a hint there, because if your absolute value equation has x's on both sides, you always have to check. So when you check, you just plug it back into the original problem. So let's check 1/3. So absolute value of x plus 1 equals 4x. To check, you just change all of the x's, or all the variables, into your possible answer. And then all you have to do is do arithmetic. 1/3 plus 1 is 4/3. 4 times a third is 4/3. Is it true that absolute value of 4/3 equals 4/3? Yes, so this is a good answer. If we checked negative 1/5, so it's negative 1/5 plus 1 equals 4 times negative 1/5. Negative 1/5 plus 1 is going to be 4/5, and then 4 times negative 1/5 is negative 4/5. Is it true that absolute value 4/5 equals negative 4/5? No. So this answer here, negative 1/5, is bad. We actually have to throw them away. This problem only has one answer, 1/3. Number 26 was another problem with the same instructions, so I'm not going to explain this one in great detail. You can look at number 25 if you need the explanation. So you set it up, first equation as is, second equation take the opposite, and then you go ahead and solve. So for the left equation, let's do two steps at once. Let's minus the x, add the 4. 2x equals negative 4, x equals negative 2. For the right equation, let's divide out the negative 1 first. 3x minus 4 equals negative x plus 8. And it's going to be the same steps as before. Adding x to both sides. And adding 4 to the other. Okay, I guess that's not the same steps. The signs were flipped. So we get 4x equals, because these guys are gone, 12, x equals 3. Now, because our original problem started with x's on the left and the right side, we have x's on both sides, you have to check your answers. And I'll just go ahead and just tell you, I won't write it down, but if you check your answers, this answer will not work, and this answer will not work. Well, we've eliminated both possible answers, so we have no solution. There's no, we don't have any more answers to check, so it's no solution. So it looks like a big word problem. So we have 5 friends, that's key there, and they're dining and they want to buy 3 salads, 5 sandwiches, 2 bowls of soup, 1 large drink, and 4 medium drinks. So they give us a table of the prices, so just match them. Salads are yellow, sandwiches are blue, soups are red or orange, and a large drink is, I think this is pink. And we have medium drinks, which is this guy here. It says find the cost each person will pay. Well, to find out, everyone's been out. When you split a check, you just divide it evenly. You divide the total bill evenly, but we got to find the total bill first. So according to the problem, we have 3 salads at $1.50 each, plus 2 bowls of soup, which is $2.25 per soup. Just 1 large drink, so a large drink is $1.05, and 4 medium drinks, which is 95 cents. That's going to be the total, so that won't be our final answer. That'll just be the total. So I'll go ahead and take a calculator and just quickly do this. So I got a total of $13.85. So that's a grand bill, but if 5 friends are splitting this together, the answer is you got to divide it 5 ways. So that gives a total of $2.77 per. Oh, actually no, I forgot the sandwiches. Ha ha ha. Ignore everything I just said. I forgot the sandwiches. I knew that number didn't look right, so let's start over. So you have 3 salads at $1.50 per, 5 sandwiches at $3.50, 2 bowls of soups, which is $2.25, 1 large drink, which is $1.05, and 4 medium drinks, which is 95 cents each. So the grand total, correctly this time, hopefully I did this correctly, should be $31.35. So split 5 ways. This looks about right, $6.27 each. Number 28 was an evaluation problem, and again, when it comes to evaluation problem, all you're doing is changing the letter into the number that they tell you. So everywhere I see an A, I'm going to substitute a parentheses, -3. I always use parentheses when I substitute. So 2, instead of A, write parentheses -3 cubed, plus 2, always use parentheses, -3 cubed. And then all you have to do is just do the math. -3 cubed is -27, plus 2 times -3 is -6 cubed. So 2 times -27 is a -54. Plus -6 cubed is -216, and then -54 plus -216 is -270. Number 29, state the property that is illustrated. There was nothing to figure out. These properties, you either know it or you don't know it. But the one thing, what are the hints? What are the things you should be looking at? There are two things that you should be looking at. Number one, oops, that's not what the problem is. There we go. Number one, notice that the order did not change. On the left, it goes 3, 5, 7, and on the right, we have 3, 5, 7. So since the order did not change, terms did not move, it is not commutative. Another thing you should notice is that the stuff inside the parentheses change. Here, inside the parentheses, 5, 7. Here, it's 3, 5. So the grouping has changed. Either one of those notices, hey, order stay the same, or hey, the grouping change, tells you I associated things differently. It's the associative property. Now, since it's multiplication, that's what we're using. You can say the associative property multiplication, but if all you said was associative, I gave you credit for it. Number 30 is an evaluation problem, so it's just like, I think it was number 28. Just go ahead and wherever you see the letter, you substitute it for whatever number they tell you. So in this case, wherever I see a Z, I'm going to change it to a -2, and again, I always use parentheses. So this is 42 minus -2 over -2, parentheses -2 plus 4, and then you just go ahead and do math. So the numerator is 44, and the denominator is 8, and then you go ahead and simplify that as much as possible. So that's what, 11 over 2. More evaluations. This time they give you 2 letters. Ooh, should not be any difficult though. Same idea. Wherever I see an X, change it to 1/6. Wherever I see a Y, change it to a 3. So this is 7 plus 5 times 3 divided by 3 times 1/6, and then you just do math. So 5 times 3 is 15 plus 7 is 22. 3 divided by a 6 is 1/2, and I hope everyone knows that when you divide by a fraction, you multiply by the reciprocal. So the answer should have been 44. Again, number 32, state the property that's illustrated. You either know it or you don't know it. But what are some things I look out for? I see parentheses, but notice that the parentheses are the same. So the grouping did not change. So I did not change the association. If you look at the order, 3, 5, 7 went to 5, 7, 3. I changed the order. I moved things around. That's the classic sign of commutative. The commutative property of addition. A rectangle is 5 feet longer than it is wide. I hope everyone can sort of understand in this problem that the dimensions of the rectangle, it's with respect to its width. Like everything is dependent on its width. I'm basing the size off of its width. Whatever the width is, the length is 5 feet longer. So whatever your quantity is based off of, that will be your variable. So my width is x, and my length is 5 feet more. And it's giving you information about the perimeter. Oops, I wanted to highlight. It's giving you information about the perimeter. And I hope everyone knows that the perimeter is just adding up all the sides. So if it's a rectangle, I know the other 2 sides should match. So just add them up. So if I do x plus 5 plus x plus 5, that should be the perimeter, which they told me was 34 feet. So then you just go ahead and solve it. Let's combine like terms. X, and x. So that's 4 x's. Plus 5 is 10. Equals 34. And that's just a simple equation to solve. So subtract the 10. Divide up the 4. X equals 6. But we got to be careful. In our picture, we said x was the width. right? X is the width. The question says, what is the length? So we have to remember the problem said the length is 5 feet longer than it is wide. So if all this math here is for the width. Therefore, the length is 5 feet longer, which is 11. So 11 should have been the true answer. 11 feet. Number 34, solving an equation. But hopefully by now, after doing the entire exam, we get a better idea of how to solve. It looks pretty complicated, so I'm going to clean them up by breaking down the parentheses with distribution. So distributing the 4 on the left gives us 8x minus 12. Distributing the negative on the right gives us negative 3 plus 2x. I'm going to go ahead and combine like terms here. Nothing to do on the left, so I'm just going to copy them down. And then I'm going to move all the x's to one side and all the numbers on the other. Hopefully we can do this in one step. So I'm going to subtract 2x from both sides. And I'll go ahead and add 12 to the other side. So that's 6x, these guys are gone, equals 15. These guys are gone. Divide out the 6 and reduce as much as possible. So dividing out a 3 gives me 5 over 2. Last but not least, another simple solving an equation problem. Again, let's see if we can do this 2 steps at once. I'm going to add the 3x over just to get all the x's together. And I'm going to subtract the 8 to get rid of the regular numbers on the right, because that's where I moved my variables. These guys are gone. This is negative 3. This is 10x. These guys are gone. Divide out the 10. You get negative 3 over 10.